Got it. Thank you. Okay, cool. Now, there we go. So before we get started, I just have a few updates. So if you are not on our general mailing list, which probably means you're new here, hello. I'm Ryan, welcome to NUMA. If you want to get more information on all of our weekly meetings and official opportunities through NUMA, sign up for our mailing list. It's in our link tree. And if you want to become an official member, which means you'll get exclusive opportunities like job opportunities, as well as access to free conferences and other fun events like that through NUMA. That information is to the top right. On top of that, we also have a Slack this year, which is a lot easier for a lot of people for getting information. So you can scan the QR code there, also in there. And we have a community service opportunity coming up, which Alyssa will tell us a little bit about.
Yeah, hey guys, I hope you guys are doing well today. So basically on Friday, we're getting a few students together to talk as panelists to high schoolers in 11th or 12th grade enrolled in the Business Pathways program at Charleston High School. Essentially, the line of questioning will kind of be something along the lines of, how did you choose your major? What are the different business classes you've taken? How do you go about navigating that? And so if you're interested, please feel free to either shoot me a message over the Slack channel, which I am also on, or you can just privately message me today.
Awesome. And that's this upcoming Friday. So that'll be exciting. We have a few people already signed up. So I think we're all set on updates. So now we're going to move into our coding workshop. So I want to welcome Claire and Will. So maybe to start off, could you guys explain a little bit about what you're studying, maybe past co-ops you've had, and then we'll hop into the workshop.
Sounds good. I'm Claire. Hi, I am a computer science and business major. I've kind of been all over the place as far as co-ops go. I've worked as a software engineer at a network security company. I was a data analyst for Partners Healthcare here in Boston, which was really exciting. Got to do a lot of work at the hospitals. And then right now I'm working as an information systems manager at MCPHS, which is the university down the street. Yeah. Well.
Hey, everybody. My name is Will. I am a computer science and cognitive psychology major. Let's see, I'm a fourth year. I've worked previously at TripAdvisor. I did a summer internship at Capital One. Now I'm currently working at like a small healthcare startup, doing all sorts of fun stuff. Yeah, that's about it. Oh, I was also a TA for like 2 years for fundies. That's also a big one.
We have good teachers here.
I mean,
yeah. Will's not going to take his own horn here.
You're going to say, I know, and then just credit yourself.
Yeah, there you go. So we're going to be doing a really basic introduction to coding today. So we're operating under the assumption that you know absolutely nothing. You've never touched any code in your life. So welcome. We're going to be working with Python today, which is, we think it's a really good language to learn because it's very broadly used and has a lot of applications. I think in general, as someone that's also in the business school, I've found it incredibly helpful in just talking to people, knowing coding now. I think regardless of whether you're studying computer science or you're working in software, it's kind of important to know how to code just to navigate. And especially in marketing, I know data analytics is becoming really important. So hopefully this can at least help you guys get a little bit of interest. And if not, you can go out and explore different types of different coding languages and styles and kind of just be open to that new world. So Will's going to show us how to set up the environment that we're going to be working in today. So that way we all can be looking at the same thing and working through the same examples and go from there.
Yeah, so I just put a link in the Zoom chat, which you all should click on. It should open to a web page that like a binder web page, and it'll have some big spinning circles, and it will take a second to load, from more than a second, many seconds.
Are you
but,
okay with me sharing my screen, Ryan?
Hopefully that will work. Yes, you should share your screen.
All right, so after all of that lovely spinning circles, you should get something that looks very similar to what you should be seeing here.
And feel free to chime in if you're getting stuck or something isn't working.
Yeah. We're gonna give it like 2 or 3 minutes, just because, or just a couple minutes, I guess, because it's slow. Is there like a hand raising function? I don't really know how Zoom works, to be honest with you. Ryan?
There is a hand raising function, I think.
If I start up and if someone's isn't ready, like put it in the chat or unmute yourself and yell at us. We're not really sprinting through this, so whenever you guys have questions on anything we're doing or something we say doesn't make sense, please stop and we'll do our best to explain. So, or try and fix whatever's not working.
I'll keep the chat open too. So if you don't know how to raise your hand, I lost where it was, but you can react to something. And also you can just say like, hey, I have a question. And I'll keep the chat open. So if they don't see it, I'll kind of like go in and raise, and yell at them and raise your hand for you.
I don't
Yeah,
know.
we'll take breaks for questions throughout as we go through this. So if you have a question and you don't want to say it out loud, you can put it in the chat. We'll answer it at some point. Or feel free to chime in whenever you want, really, with questions.
Yeah, so we're gonna, kind of the style we're going through is we're gonna introduce a concept and then we're gonna do some example coding related to that concept. So that's a good time to stop and ask too. All right, is anyone not have what I have open?
We have a raised hand. Mine is still loading.
Okay.
I see mine is still loading. Like I have the circle still, I'm spinning.
Yeah.
Still got the circles.
The first time you open it, it does take a couple of minutes, to be fair, because it's establishing your whole environment, and that's a lot of stuff that we don't look at. It just kind of does it for us, which is nice.
Is
Also,
it better? Oops, sorry.
I'm sorry.
Go ahead.
Okay.
It happened to me as well. I had to turn off my ad blocker. So if you guys have ad blocker, that might be also why.
Oh, interesting.
Yeah, that could also be causing problems.
Okay, just open for me.
Nice. Okay.
Mine's still loading. Oh, nope, now it's open too.
As I say, it's just slow.
Yeah. Is everybody else good? Any other issues?
I just had a quick question. So when you say like environment, do you always code like within an environment?
It depends on what language you're using. You can do like you can run code from your terminal, which is just on your laptop, and that's in your like a command line is what they call it. Right, well, do you want to take this one?
I mean, essentially, right, like an environment is just the computing space where your code is being executed, where the work is actually being done. So in this case, right, there's some box somewhere in a data center that is actually running your code on it and showing you this web page, and it's all being run not on your local machine, but some faraway land that you are connecting to, right?
Because there's always so much happening behind the scenes. We're really lucky that we're in the era that we are and don't have to write assembly, which is just a series of ones and zeros that the computer understands. So it always has to be in an environment that understands what coding language you're using. So today we're using Jupyter Notebook, which is used for Python, the Python language specifically. So, all right.
I think we can probably get started now.
Yeah, are you Lisa? I don't know. Are you good? She put it in the chat. Okay.
Yeah, it is.
Yeah, so can everyone see my screen well enough?
Yes.
Okay, cool.
Looks good.
So we're gonna start at the very basics, and the joke that you have is you always start with one specific line of code, and that's printing. And so printing is basically telling the coding language that you want it to output something to you. So when you print something, you just type print and then some parentheses afterwards. And whatever you put inside the parentheses, it's going to output. So the most basic thing that you can learn in coding is printing hello world, because that's just, I'm clearly nervous because I can't type hello at all. And then we're gonna, oh, sorry, you guys don't have that line. If you click this Python basics box and then click insert and then click insert cell below, it's gonna create a cell that like I have here. And then after that, you can type in print parentheses and then in quotation marks inside print hello world. And then you're gonna go up to this lovely button that says run and you're gonna click it. Willow, why is it not running?
Give it a second.
Okay.
Oh, sad.
We'll give it a second. Well, it did work. Probably had it open too long, to be honest. Well, did it work for anyone else? We might be having technical difficulties. We got one nod, so we're doing okay. So that's the basics. So from there, the world is open to you. You've said hello to the world of coding. Congratulations, you're stuck here now. So we're going to talk about the really basics of coding is you have different variable types, and variables basically allow you to create code, define things, and allow you to access these different definitions and objects from wherever you're coding. Basically, your entire coding knowledge is built off of variables. So we're going to start by going through the different variable types. So bear with me, and we're going to build off of it from there. Can everyone see my screen again? Is it back? Yes, Brian, Will, someone?
Yes, looks
Okay,
good.
great.
Sorry.
So we're going to start by talking about different variables and how to define them. So defining a variable is basically typing something in, whether it's a name or a number or something with an underscore, and then saying it's equal to something else. So the most basic thing that you can define as a variable is x equals something, right? I think that was an algebra concept. You say like x equals 2, right? So for here, we can say x equals 2, and then we can click run. And why is it not? Okay. So now once you click run, you've told the system that x is equal to 2. And no matter where you use x in your code, it's always going to know that x is 2. So I can, as we did before, talked about printing, right? So now instead of saying print 2, I just tell it to print x, and now it's going to output 2 for me. So if you guys want to give that a try real quick and see if you can set a variable and print it. Any problems with that? All right, great. So now we know how to define a variable, which is very important. And we know how to print it. So we have to go through, there's a couple of rules when it comes to creating a name for your variables. When you're creating a name for your variables, it always has to start with a letter, either capital or lowercase, or an underscore. You can't start it with like 2x, cannot be the name of a variable you have. Or you could start it with like 2x, that's allowed, but it cannot start with a 2. And then you can't use dashes. So I couldn't say this is, and that's not a variable. You're not allowed to do that. So just to keep in mind, whenever you're naming things, kind of follow the conventions of underscores are allowed, numbers and letters are allowed, just don't start with numbers. And otherwise you can name it whatever you want. So if you want to make something really intuitive and say, this is my name. So I'd say name equals, and then I'd say my name is Claire. And now whenever I need to use a name later, instead of typing out Claire, which I have an easy name, so it doesn't really matter, you can just call name. So when you get into after you know how to define a variable, we have to talk about the different data types that are used in coding that you can apply to variables and that you use throughout to build kind of your code and your architecture. So we're going to start with really simple variables, which is integers and floats. So these are numbers. The only real difference is integers are whole numbers, whereas floats have decimal points. Their uses aren't too different. It's just to distinguish between the two, whether you have decimals or not. And so now we're gonna move into kind of using basic arithmetic in coding. So our computers are smart enough, they kind of know, it's already pre-coded in how to do really basic mathematics. So here we can see that I want to add 2 plus 2, but I'm too lazy to do it myself. So I'm going to have the computer do it for me. So I've decided that I'm going to add those two. So I can say print 2 plus 2, and this is going to run it for me. And wow, I don't know what's okay. There we go. We've got 4. So since I already have a variable that does 2 plus 2, instead of having to retype that every time I want to print, I can say 2 plus 2 is also known as add, so I can print out add. So there it goes. It still prints 4. If you guys want to give a try, you can write your own print statement, and you can start writing out crazy numbers like that. And it's really smart, and it's going to be able to do it in 0.2 seconds. Simple enough, right? Addition, yes. Any problems with addition? Okay, cool. It's basically the same thing with subtraction.
Hey Claire,
Yeah.
if you run those first 2 cells with where you set those variables.
Oh, is that why you did it that way? Okay.
Yeah, it'll actually save them in the kernel. So run both of those.
All right, thank you.
Yeah.
So if you didn't hear from Will, it's basically what I said is X and Y and then F1 and F2 are defined in the system as soon as you run them. So if you, like you said, put the cursor in there and click run, and then the system for all of these cells throughout the entire document is going to remember that X equals 7, Y equals 12, and then F1, which is float 1, equals 12.3, and F2 equals 5.4. Yeah, sorry, I'm jumping around a bit. Yeah, so basically we have basic arithmetic, which is addition, adding, and then we have subtraction, which does all of those basic lovely mathematical things. Multiplication is also super simple, same as addition. It's basically, we use this lovely star character to represent our multiplication in coding. So we can see here, we can print out mul. Nothing too exciting or too complicated, I don't think. So basically anything that's either a variable representing a float, or an integer can be used with addition, subtraction, multiplication, and division, and you can print out those values. So what I did here was I showed you just have your 10 times 3, it's the basic integers, and that's producing the value 30. But you can also print z, which here is x. So x is represented, as we set up here, by 7. So it's taking 7 times f1, which we said is 12.3, and it's multiplying those out because it remembers the whole way through. So like I said, you can intermix floats and integers. They're just different variable types that are both numbers. And you can multiply variables as long as they are either integers or floats, and they're through their variable representation. Any questions on that? Any confusions?
Cool. My thing is when I type in print z, it's giving me like a literal z and not like the value, even though I ran the integers and floats values.
Okay.
Do you have your z in quotes?
Yes.
Okay, so
Right.
we're going to get to that next. So when you put your z in quotes, that means it's a string. So it's not representing the actual variable z, it's representing the letter z. So just when you put that there, make sure, it's nice that it color codes it. So it's just this black C right there instead of the red that's represented by the string. And that way it should output the same thing that I have.
All right, that
Sorry.
fixed it. Thank you.
Awesome. Yeah, sorry, that's next. We're doing strings. Yeah. So one concept that's mathematical that's not as commonly known is called modulo. It's basically division, but instead of giving you a decimal point, it takes the remainder of the division problem, and instead of turning it into a decimal, it just says, okay, 16 divided by 5 isn't 3 point whatever, it's just 1 because there's a remainder of 1. So if you take 15 and you modulo it by 5, the answer is going to be 0 because 15 divided by 5 is a perfectly even outcome or divisible outcome, right? It puts out a whole number, not a decimal. So modulo basically says, okay, the remainder of that is whatever. So anything from 0 to 4 can show up there. I don't know if I did a good job explaining that. Will left. So here we have mod equals 15 modulo 5, and the modulo is represented by a percentage sign. And so we know that 15 divided by 5 is an even 3. It comes out as a whole number. So the answer to mod, if we were to print out just mod, we would get a 0. So we see that 15 mod 5 is 0, but since 17 divided by 5 is not a whole number, if we did mod 2 and we ran that, we would have a remainder of 2 because there's 2 numbers in between 17 and 15. This is interesting later on, especially when you're trying to decide like even numbers versus odd numbers in a sequence, and you can narrow it down there. Any questions on modulo? I don't know if I'm doing a good job of explaining that. Sorry. I can't see any hands, so I'm gonna accept that was good. And then the final arithmetic kind of expression that we have that's built in, that's super popular, is doing to the power of, and that's represented by 2 of the star or asterisk signs back to back. So here we have 2 to the power of 3, and if we were to output that, we would get 8, right? Basic enough. That's arithmetic, and I hope that's I explained that well enough. So if we want to get some practice in, I left a little bit of space where you guys can try and just print out expressions just to get used to typing, and then kind of printing out variables. We can take like 2 or 3 minutes to do that, and you guys can just play around, can put in crazy numbers. You can try things that you think might work and they might not, and maybe I can explain them. And then we'll move on to conditional expressions. And if you guys need an example, obviously you can look back and kind of see what we already did. They're all still there. So, or you should have the same thing that I do.
If you accidentally reuse a variable, would that give you like an error?
You said lose a variable?
Like reuse it. So if you have like a variable set to a number, then you have it set to another
Right.
number.
So it's basically going to override it. So if I said in this box down here, if I said my name equals, or let's say my age equals 20, right? And I used it, but then I did like, if I said it again and said age equals 21, it's going to change it. So if I print it here, it's going to tell me that my age is 20 because I haven't quite reached the second setting where it then sets age to 21, right? But then if I print it again down here and I say print age again, it's going to print my age as 21 because it reset it, right? So even if so if I print that, it's going to tell me 2021. But if I take out that print, it's only going to give me 20 because it's only reading that age is set to 20 when it outputs. Yeah, so that's something you can do later on. There's concepts where if you set something to a number, you can increase that number, you can change it, and we're going to get to that later, actually.
Thank you.
Yeah, of course. Does anyone want more time to play around with the basic math, or if you want me to move on and you're just sitting around, I can do that too. I can't really see anyone's screen, so I don't really know how much time people need. All right, I got 1 thumbs up. 2, 3. Okay, cool. All right, we'll move on. So another data type in coding is called Boolean. So it's spelled Boolean. And it's basically means true or false. So you can basically in your coding, sometimes you just need to know whether something is a yes or a no, right? And so we use true and false statements. So we're going to kind of go through how those are used. And we're going to look here. We have a print expression, right? So printing isn't just for variables or numbers. You can also ask it to output an answer, right? So here we're asking it, is 1 less than 2, right? So we know that 1 is less than 2. So it's going to tell us that that's true when we run it. So I get the statement here that says, yes, 1 is less than 2, which is good, right? And then we can ask it a lot of other questions that have to do with greater than or equal to. So I can say, is 1 greater than or equal to 1? And we can assume that it's also going to put out that that's true, right? Because we know that 1 is greater than or equal to 1. So we can run that, and that also says true. But then we can get into more complex things, like we can ask it, is the variable x equal to y? And so one of the things that's built in is instead of just saying an equals sign when we're comparing two things, is you put equals equals. So that's just syntax that you kind of have to remember. Same thing as like the percentage for modulo and the asterisk for multiplication. So we have these 2 variables set up here. We have x equals a and we have y equals b. So when we ask it, is x equal to y, it's going to tell us they're not the same thing. So we run that and it tells us, that's false, right? So it's good for not only comparing numbers and doing evaluations that way, but you can also compare concepts or other variable types like strings and objects. Another concept for conditional expressions is using and and or statements. So and or statements are asking it if something is an or, you're asking it if this one statement is true or this other statement is true, I want you to output that the whole thing is true. So here we have a print statement where we're asking it, is 10 less than 3, which is false, right? 10 is greater than 3. Or is 17 less than 16, right? And neither of those are true, right? And since neither of those are true, it's going to output that that's false, right? But if we come down here and we say, okay, 10 is less than 3, that's still false, or 17 is greater than 16, right? Since 17 is greater than 16, that means that conditional expression is true. So since it's an or statement, you want to know if one or the other is true. And since one is true, it's going to return true. Any questions about or statements having to do with true and false? Cool. So similarly, we have an and statement, which says that in order for something to be true, both statements have to be true. So it has to be true and true. So when we look at this statement, we have 10 is greater than 3. So yes, that is true. And 17 is greater than 16, right? So since we have a true and a true, we're going to output true again. But if we have in this statement where we're saying 10 is less than 3, which is false, that means that the statement is going to be false because not both of the statements are true. So we run that and we get false. So it doesn't always have to be written out as it's solving a problem, like greater than or equal to. Sometimes you can just say true or true, which is what I have down here. So we know true and true is going to turn out to be, anyone? True. And then we can kind of go down the line with those. But here we're going to introduce the concept of not. You can also say in a conditional statement that you want the opposite of something. So here we have it saying that something is false and false, right? So if it's two falses, that's still a false, but we want it to not be that. So we want it to be the opposite of false, which is true. So this print statement is going to output a true because the opposite of false and false is true. And there we go, we got a true. So I put a couple of these down below in the box right under that. And I put a little place where you can write in what you think the answer is. And after you've answered all of them, you can just run that cell. And if you don't get some of them right and you're confused why, feel free to ask. And we'll give a couple of seconds to run through that. Does anyone need more time to run through those? Okay, yeah, we'll wait.
I'm just a little confused on where they're getting it. So in the box where we're doing the practice, how is it linking up to the statements in the box above it? And which of those statements is it running for the true and true or false?
So these are completely independent. They're not based on anything else. So they're built into the language itself. It's not anything you've written. So true and false aren't variables. They're data types. So the programming language innately understands that when you say true, you mean that they've coded in that it means true, that this is correct and accurate and true. Whereas false is no, wrong, it's false, right? That's not something that you wrote. And if you try to write it as a variable, it'll misinterpret that as the true and false that it understands. So this is completely independent from anything you've done in the other box. So like I said, the computer innately knows that true means true and false means false. So when you're doing it in this this practice, these 4 practice ones right here, it understands that true and true is always going to be true, right? It isn't reliant on anything else except for internal systems and stuff.
Thank you.
Does that answer? Okay,
So yeah, it's similar to like, you can think of Booleans can be represented by numbers, right? Like you could have a 0 and a 1 for true and false, right? And it's a similar idea where they're atomic types and they're not variables. They're these innate things in the language, like Claire said.
Yeah, no, that's a good question. Sorry, I did not explain that well. Anyone else need more time? Or any other questions on that? If you didn't get it right, do you understand why? If not, can I answer anything?
Send a thumbs up if you're done. React with a thumbs up.
Nice. Okay.
Physical thumbs up is also great.
Yes.
Yes. Very nice.
Awesome. Okay. So yeah, so if you got it to output the answers, they're there as well. So true and true is true, but it's not, so it's false. And then we got a true or false, which is true. And then we got a false and true, which is false, but not that. So we need a true. And then a false and false is a false. Cool. All right, so now we're going to move on to strings. And so we kind of talked about this earlier, why things are in quotation marks. And so when things are in quotation marks, that means they're of the variable type a string, which is basically a word. So the computer is going to always interpret that as this is a string and everything inside of it is one string, and you can kind of write sentences with it. You can put spaces in it without the code getting angry at you. So kind of like we did hello world, right? It knew that that was a string and to output just the things in those quotation marks. So you could say hello space world in it. You can use double quotations, which is what I have here for my name. You can use single quotation, or you can use just the apostrophes. It'll also understand that as a string. And like I said, you can make full sentences without with spaces in it, and it understands it. And then another cool thing is if you put numbers inside of the quotation marks, it's going to also understand that as a string and not as the numbers. So if you tried to add 34 and 72 while they were both in quotation marks, it wouldn't give you an addition value. It would give you those two things next to each other. So you get 3472, which we're going to kind of look at. So we can, if you guys want to try and just practice kind of making some variables that are strings, it's pretty straightforward. You can just say, example equals, this is a string. Yeah, so if you guys want to play around with that, I find that it can, when you first start coding, it can be kind of intimidating, but the more you type out and the more you mess up, the more confident you feel in it. So that's why I kind of keep stopping to let you guys type things out. So one of the cool things that you can do with strings is you can take independent variables and you can mesh them together, which becomes important later when you want to make changes to your string and the values inside of them. So that's called concatenating. And what you can do is you just basically add them together. So what we have here is we have our sentence, which we defined up here through our variable sentence, right? So the computer understands this to be, this is a string as a sentence, and then we're telling it to add together with a space. So whenever you put quotation marks and just leave it blank, it does interpret that as a space, and then we want to add it with my name, right? And my name up here is defined as Claire, right? So when we print out con, which is for concatenate, we get this is a string as a sentence Claire, right? So you can do that with a variety of different things. So you can add before and after. the ordering doesn't really matter. You can kind of just throw it all together. You just have to remember that you have to put the pluses in between, otherwise it'll get angry at you and you'll get a lot of error messages. So if you go down to this example box below, it says below create a new string by spelled incorrectly, concatenating two or more other strings. So if you guys want to give that a shot and create your own variables, 1 or 2, and then, or you can just concatenate 2 quotations together. You can try that and let me know if you have any problems. Cool. Great. So hopefully you guys can now concatenate strings together. So that's nice if you decide you have, you want to grab parts of one data type and put it with another, or not data types, excuse me, parts of one string and put it with another. And that comes in handy when you get into more complex coding later. So another thing that you can do with strings that's fun is you can grab only parts of a string, right? And this becomes important when you are looking at larger amounts of data and you decide, okay, here's a whole URL of a web page and it's in my database, but the only thing I really want out of it is like the .com part. You don't want like all the messy like letters that don't really mean anything afterwards, right? So when you go to analyze this, you can say, okay, I just want to grab this specific part of the URL, and you do that by using a thing called substring. And so basically you tell your coding and you decide, okay, I only want the characters in position 1 through 10 to appear, and anything else after that I don't really care about. So you're going to write that out by using these brackets right here, and you're going to pick where you would like to the substring to start and where you would like it to end. So if I'm looking at this sentence that we have up here, right, called sentence, this is a string as a sentence, and I decide that I want to only grab the word this, right? So we count out the characters in a string by starting at 1. So the T is indexed, is the technical term for it, by the letter 1. So then the H is going to be 2. The I is going to be 3, and the S is going to be 4, and then the space is going to be 5. So when we're indexing, you count spaces and apostrophes or any like grammatical like part of the message as well. They count as a quote unquote character. So I've decided that the only word I want out of this sentence or out of the sentence variable is the word this. So I'm going to say that I want, like we have here, we're going to grab it and say I want the first word, and I'm going to grab the variable. So I write the variable name first, and then I'm going to write these double brackets, and then inside the brackets I'm going to write the index that I want, which in this case is 1, and then you're going to put a colon and then the last index you want. So if I were to print out first word, it's going to give me just the word this, right? But the nice part about coding is we're super lazy, so you don't have to put the 1 in there because you're just telling it to start at the beginning. So if I were to print out first word, it's going to give me the word this, right? And if you all want to write print and try that out for yourself, go for it. And you can try indexing anything out of that you want, right? By putting in different numbers in there. So I could say I want indexes 3 through 4 from this string, and it's going to give me just the letter S, right? Because we've stopped at 4 and we started at 3, so it's just the letter S. I have 2 other examples there. which is not the first word, which is basically taking, outputting the space and then is a string as a sentence. And then we also have random, which is just showing you if you don't want to start at the beginning or the end of the string, you can fill both sides in of those brackets. Any questions on substringing?
So wait, why did it print out this and not like the fourth word?
The fourth word?
Yeah.
So
when you hit print.
yeah, so it's grabbing, when you talk about indexes, it's grabbing the fourth through the fourth letter. So each 1, 2, 3, 4 is based on a single character in the string. So like I said, the T is represented, the T in this is a string as a sentence is labeled 1. So if you wrote it out on like a number line, you could label each of them. And unfortunately, we're not in person. Otherwise, I definitely would have. And so
But
then
zero,
you keep
but
going.
yeah.
No,
Okay.
it's Python. It's Python.
No,
It's Python.
0 indexed.
In
I
Python?
promise. Yep.
Okay.
Oh, because it's based on letters. Okay, I got it.
Yeah, so it's
Yeah.
character by character is what you're doing.
Okay.
So the first one goes from
I don't think that's right.
index 3 to 4.
Okay.
We can try and explain it better if that doesn't help. Now, well, I'm telling you.
And I think that was good. That was good. Thank you.
Okay. Yeah, so that's, you can grab different parts of a string, and if we want to get really complicated, we can say, okay, I just want, instead of this is a string as a sentence, I just want to change it to this is a sentence. So you can substring our sentence and just grab this is a, and then you can concatenate it together with the word sentence from our original thing, right? So we can grab sentence and then 0 through, what do we get? 4, 5, 6, 7, 8, 9, 10. So we're going to grab through 10, and then we're going to add that to sentence. And I think it's 11, 12, 13, 14, 15. And then grab through 22 through the end. And then we want to put new sent equals that. And we should hopefully get this is a sentence. There you go. So you can combine different concepts to get a totally new variable out of that, which is fun. Any questions on that? Cool. All right. So there's a lot of other built-in functionalities that Python has. We obviously won't go through them all. Oh, sorry. No. So the brackets and the parentheses are all based on what situation you're in. So when you are doing a substring, the system knows that the brackets represent that functionality, right? So by putting the brackets around the 1:4, it knows that you're trying to substring that, right? Whereas with this, when concatenating, it knows that you're just trying to add, right? You're trying to put them together. So you're trying to say sentence, or say this output plus this output, right? So it is very important whether you use brackets or parentheses, because it tells the system what you want to do out of what you're saying, right? So if I just replace this with brackets, it's gonna yell at me. Oh, well, I mean, that works too. So it told me that, so it set new sent as this is a sentence, and then it put it in quotations because I need to know that it was a string, and then it output the brackets as well. So it doesn't give you the same output, but I don't know why that didn't yell at me. Why did that not yell at me?
It just makes it into a list if you put brackets around it.
Oh,
So that was just a
right,
list
right,
with
right,
one
yeah.
thing in it.
Okay,
Yeah.
we'll get to that next. Cool. So like I said, there's a lot of other functions that are built into Python, but we won't get to go through all of them because we'd be here for an actual 20 years. And so just some of the other really commonly used ones are length. So if I want to know how long the string is, I can just do an automatic call on the function len and then put that in parentheses and it'll tell me how long my name is. So some people use this to say, okay, if anyone's name is longer than 10 characters, we're going to remove them from this data set, which seems really odd, but kind of things like that. And so then you can say my name or print length. And then it's going to tell me that the length of my name is 6 characters long. Anyway. And then another thing that you can look through is you can use indexing and ask it, okay, I know the set of characters string is inside my variable sentence, and I want to know where it is inside that string. So if you say, okay, here's my variable, and then put a dot afterwards, and then call index on it, it's going to tell you where inside that string the word string is. So it tells you that string starts at character 10, right? Which we counted earlier, and we know that's true. Similar for the second one down here, just something important to note is that it tells you where the very first occurrence of that is. So it's telling you that the very first occurrence of I appears at the third character. It's not talking about the I in string or the I in is. So it'll call that for there. Any questions about strings, kind of their functionality and the basics of playing with those? Cool. Okay. So I kind of had you guys already work on concatenating, and why don't you take a second and try and do work on the substring functionality and pull the word yes from the sentence I want to answer yes, not no. So just create a variable for that real quick. So we can just call it variable equals this, and then try and pull a substring of that that's just the word yes. Does anyone want more time, or I can type out the solution?
Thumbs up when you're done. Thumbs up on Zoom. I love the thumbs up.
We'll give it a couple more minutes. I know it takes a long time to count all of all of the characters.
Yeah.
Okay. We'll move on to lists then. So lists are another data type that's a little more complex in Python. So a list is made up of other data types. So it can include integers, floats, strings, booleans, any of those. So you can see in your examples there, you have a list that's all just numbers or integers. Then we have a list that's all of just strings. And then we have a list that's a mix, right? You can cross them. You can kind of throw whatever you want in there as far as data type goes. You can even have a list of all just variables. So a list is classified by having brackets, and then each each variable or each data type or each example is separated by a comma, and that's how you know that that has ended. So we know 1 is one piece of data, we know 2 is another piece, 3 is another piece, and then 4, and so on and so forth. Otherwise, it would get confused and not understand why, not understand that it's in a list, right? So we can use lists in a lot of, oh, sorry, Erica, did you have a question? Oh,
I just couldn't get it to like spit out
Oh,
anything
yeah,
more
yeah.
than Y.
Okay. So what it does, sorry, I don't know why I can't see the like hand raises or anything like that. So when you're doing a substring, did you get the formatting right? So did you see mine? It's, you want to put the variable name and then the brackets, right? Did you get that far? And you got
Yeah.
it to output. So what numbers did you choose as the characters?
So I put the 19. It just, I tried putting the colon on one side and then the other side, and like I tried 20 and 21, but I guess I must have miscounted.
Yeah. No, you're good. You're good. I did
It
2
works
at first because I put 21. I was like, oh, that's not right. So you just move it over one. Yeah. So if you try 19 through 22, does that give you what you want?
Yes, thank you.
Okay, cool. Yeah, no problem. And the fun part about coding is sometimes it is just trial and error. That's the honest truth. Okay. So lists, yeah. So a list is basically just a way of keeping a lot of data together in one variable type, right? And so obviously we're at a very small scale now, but you can have lists with like thousands of data points, right? And obviously if you have only 1 or 2, it's easy to keep track of and kind of just throw them in there. But when it becomes kind of unwieldy, lists become really helpful. So we're obviously today focusing on them on a smaller scale, but it obviously is applicable at that larger scale as well. So yeah, so like I said, it's applicable to all data types. So we even have one here that can keep a list of Booleans. So we have trues and falses, and then that's just another example. So we're gonna start by looking at indexing. So when you have a list, sometimes you want to be able, you don't have the list just splayed out in front of you like this. So sometimes I just know I have a data type, it's called nums2 or it's called ABC, but I'm not really sure what's in it. But I want to know where in that list a certain data type is, or a certain object is located. So I know for a fact, just because I knew that somewhere in the variable ABC, that list, there is a string that just contains A. So by looking at indexing, we're able to go into that list and it's going to tell me, hey, the string A is in the first position, right? So if I went and I printed out position A, it's going to tell me that is it. Well, like, so this is so in coding, in most coding languages, it's very odd how we count. Instead of starting at the number 1, you start at the number 0. So like this is A is in that first position, which means it's at index 0. Python's one of the ones that uses that. Thanks, Will. So I can know just from the outset without looking at the actual data type, or like at the actual variable naming, that that A is at index 0, right? So that's the same for this. So if I were to print out position B, it would tell me that B is located at index 1, right? So if I wanted to do something with A instead of, or some data in the list, instead of saying, oh, well, I want this, and having to run through thousands and thousands of data points, I can instead just say, okay, the data point at index like 10,000 is going to do this, right? So it makes it a lot easier to keep everything organized. Another thing you can do, like I said, when you get lists to be very large, is you can call a count. It's the same as a string, and it's basically telling you how many objects are inside your list. So here we're calling it on nums2, and I'm specifically asking it to tell me how many times does the number 4 appear in the list nums2, right? So I could go through here, obviously, and count, and I could say, okay, this isn't a 4, this isn't a 4, that's not a 4, that's 4, 4, 4. But I have 1, 2, 3 4s at the end. So obviously now I can count it, but once again you get into these bigger data objects and things like that, you can't really manually count it. It's not really worth your time. So we have this lovely function that tells you how many there are, and it'll spit that out for you. So we can run print total right here, and it's going to tell us that there are 3 in there. We got to get rid of this other one. That there are 3 4s in the list, right? Very helpful. Again, very similar to the previous one, we can look at the length of the list, and it's going to tell us how many there are in the list. That's pretty straightforward. And so it tells us that there's 3 in the list var, right? So we have, this is our list that's called var. We have 1, 2, 3 objects inside the list, and it tells us that there are 3. All right, cool. So obviously you can make a list, and you say, okay, I'm going to make a list of my favorite foods or something like that. So you say, call it food, and you're going to say, this is or how about you're going grocery shopping and you need a list of groceries, right? And so you can make a list. And so a list is created in brackets. And then I'm going to say, I need milk, and I need eggs, and I need sugar, and I'm like, okay, great, that's my shopping list. But then later on, I run that, and now the system knows that food that I need is milk, eggs, and sugar. Well, I decide later on, I'm like, crap, I also need to add like butter to that list of things that I need. So instead of just creating a whole new list and typing this out for a second time, or going here and adding it, again, keeping these really big like larger data sets in mind, we have this function called append, which basically adds another item onto the end of the list. So for our food example, we can say food. So we're grabbing the name of our list, and then we're going to put a period after that. And I'm going to say I want to append. And then in parentheses afterwards, I'm going to say I want to add butter to my list. So then I run this, and it has added butter, and then I click print, and it's going to output that new list with butter in it. Cool. But then you can also, similarly, you can remove things. So here I've appended the butter, but then I can also remove the butter. Something important in coding in general to keep in mind is that everything is case sensitive. So if you type in, if I capitalize the B on butter for the append, but not the remove, it's not going to remove anything because it doesn't recognize that they're the same object. It thinks they're different. So here it is after I appended it, and it says there's my butter, but then I decided to remove it. So now there is no longer any butter. And that is appending and removing to a list, and you can do that a million times. You can do it with multiple objects at the same time, or you can do just one. Any questions on these functionalities of lists? Cool. All right, so we're going to move on to another data type called a tuple. And a tuple basically acts very similar to a list where you can store all of these things or all of these data types and different objects, except you can't append or remove to them. Once they're a set number, that's it. You can't make them grow in length, and you can't remove from them. And that's about the only difference. Yeah, they're not as widely used. I haven't come across them. Okay, so now if you guys want to take some time and play around with creating, with tuples, the only difference in creating them as an object is tuples use parentheses, whereas lists are use brackets. And then if you guys want to take some time and practice creating lists that has at least 4 values in it, maybe try and remove something from the list or add something to the list. And I'll give you guys like 5 or 6 minutes to do that. And if anyone has any questions or problem with that, just let me know. Whenever you guys are done, just give a thumbs up in the chat and we'll go from there when I see a couple.
People feeling good? Yes. Thumbs up. People, thumbs up. All right. Claire, you are muted.
Sorry. Okay, cool. If anyone doesn't have any questions about that, we can move on to dictionaries. So dictionaries are really useful for keeping track of a lot of information that's interrelated. So if you take a look at the dictionary here, it's kind of, we could just call it a student, right? Instead of a dictionary. So here we're keeping track of someone's name. So we have a string here that says, okay, this is a name and the name is Sam. And then we have an age and the age is 20. And then we have a major, it's chemical engineering, and they have a GPA, it's 3.7. So in dictionaries, you're able to keep track of a lot of different data types and a lot of information that's kind of all coagulated together, which is nice. And they can become extremely large, but it's nice because they're really organized. And when you're looking for information, you can kind of say, hey, I want a name, and you can just say, give me the name, right? It's very similar to the idea of a database. You go in, here's what your column's named, and you grab it. So here we have an example of wanting to grab the age from the dictionary. So I know that it's called a key in a dictionary, the label of it. So I know that my key in this case for finding out how old this person is calling it age. So I go and say, okay, my dictionary's name is DIC, and then I call the key, which is age. And so it should spit out 20. So telling me that the person's age is 20. So if I printed age grab, it's gonna tell me that they're 20 years old, right? So similarly, you can also go in and you can change information in a dictionary after it's already been created. And you can do that by calling the dictionary or the name of the dictionary, which in this case is DIC. And we're going to say, okay, the age of this person is no longer 20, it's 21. So I'm setting the key, which is age, its new value to 21. And then, yeah, and you can do that with any of the keys inside a dictionary. So the keys in this case are the name, the age, the major, and the GPA, and then the information that it leads you to is Sam, 20, chemical engineering at 3.7. Any questions on dictionaries? Or Will, do you want to elaborate on those at all?
No.
Okay.
That's a
fair description.
Yeah.
Okay, cool. Anyone have any questions on dictionaries?
So after the dictionary, if you hit print age, it would give 21.
So you would, yeah. So if I went down here and I uncommented this out, and so it's going to tell me that the age is 21. So similarly up here, before I've reset it, if I did age grab, this is going to tell me that at this point, his age is 20, right? Because we haven't hit here where I'm resetting it. But if we go to this print and tell it to just print that, it's going to tell me he's 21. So since we're doing both, it didn't do that. Will?
You didn't you're doing age grab, so you didn't reset age grab.
Oh.
Yeah.
Okay, that's why. Yeah, so his thing in there is
Yeah, if you printed dict age or whatever.
Yeah, you're right. Sorry. Cool. There you go. Now it's 21. So you have to reset the grabbing the age each time. And so since I didn't grab that his age then, it was still 20. Does that make sense, or did I confuse it more?
I know that makes sense.
Okay, cool. Great. So dictionaries. So now that's a lot. That's the basic data types that you're going to be using throughout coding. And from there, you're just going to build everything on top of that. So now we're going to go into building actual statements where you can kind of make calculations in the code and it can solve things for you. And we're going to start with if statements. So an if statement is basically saying if something is true, do something, and if it's false, do something else, right? So we can ask it if something plus something is something else, if it's true, if it's false. The sky's the limit on that, more or less. So we're going to go through a couple of examples here of if statements and how they're built. So in Python, the syntax for writing an if statement is you're going to start by writing if, and then you're going to follow it by parentheses. And inside those parentheses is where you're going to put what you're asking it. So you're saying if whatever's inside there is true, or if it's true, then you do the next thing. So here in this first example, I'm saying, okay, if variable x plus y is equal to 10, then I want it to do whatever follows, right? So for the sake of keeping it simple, we can just say if 1 is less than 2, and then you finish that line off with the semicolon, and that's just the internal syntax, so it knows that your if statement is done. And then you're going to click enter, and you're going to go to the next line, and whatever you put on this next line is what the statement is going to do if whatever inside that parentheses is true. So if 1 is less than 2, I'm just going to say print 1 is, I'm going to do a string of 1 is less than 2, right? And the you don't have to put anything at the end. It just knows by you indenting that there that that's the outcome, right? And so that is a basic if statement. So in this case, for our first example, I had if x plus y is equal to 10, so we have 3 plus 7 equals 10, then we want it to print that's the correct total, right? So if I were to run this, the very first thing it's going to output, sorry about that. The very first thing it's going to output is correct total, right? So we know for this if statement, it is true, so it's outputting that. But in this example, we don't have anything if it's false. We just don't do anything if it's false. It just ends there. Any questions on how the syntax for a basic if statement works? Does everyone understand the inside of the parentheses is what you're asking, and the next line is the outcome of it being true? Cool. Okay, so like I said, you can do this with, it doesn't just have to apply to numbers. This can apply to all data types. So our next example right here has to do with a string. So I'm asking if the string here, this I said bad word, is inside, and then whatever is here, then if that's true, then you want to print what's right here. Then in this case, it's a string that says contains bad word, right? But if it's not true, you don't do anything, right? So this is it's very similar to asking if something's inside of something, right? So you can say just one letter. So if I was looking to see if there was any of the letter A inside of a word, you could say just if A is inside whatever you feed it, right? So I could say if A is in, and then I can just say this string, which you can say my name, and then put our semicolon or our colon, and then we ask it to, we can just tell it to print true. And so then it'll output true because I have an A in my name, right? So it doesn't have to be super complex, but the more complex you ask of it, the it has to be correct to the T, right? So if I had, if I capitalized this being bad, it's going to tell me that that bad word is not inside sentence because, like we said, capitalization matters. Cool. So another kind of syntax thing in code is that instead of saying not equals to, we put a little exclamation mark in front of our equals sign. So this is the same as saying not equals to. I know there's a lot of like little syntax things that are hard to remember with the parentheses and stuff, but the more you do it, the more you remember it, and it gets easier as you go. So here I'm just saying if x is not equal to y, then print this. And so since it is true that x, which is 3, is not equal to y, which is 7, then I'm going to print not equal. So then if statements can get more complex and you can ask it more than one thing. So down here we have, I'm asking if x is greater than y. So 3 is not greater than 7. So we know that this statement is not true. And so that means you're going to hop down to the next one, right? So you're going to say that's false. So I'm going to check the next if statement, and that's known as an elif. So you're just saying else if the first one's not true, check and see if this one's true. So then I'm asking it, is x equal to y? And so in this case, we know that's not true because 3 is not equal to 7. So we say that's still false because if it was true, we would print out that statement. So I go down to the last one, which is an else statement, and I say, okay, no matter what, you're going to output this because you've run through all the other options, right? So in this case, it's going to print out y is greater than x because we know it's not true that x is greater than y and x is equal to y. And that's more of a traditional if statement. You would say if something is true, do this, and else do this, right? Any questions on how if statements work? Cool. Okay, so I created a couple examples down here, and I'm going to give you guys a little bit of time to go through them, and then I can put up the solutions and I can answer any questions that you guys might have about that. Yeah, thank you guys for coming who are leaving early. I hope I could teach something.
Yeah, and this will all be available afterwards too. I'll send a link to Ryan or something for so you can all access this later.
Yeah, I'll give like 2 minutes and then I'll put up the solutions and we can go through that. And if you guys are having trouble, you can definitely look back at the examples. They're really helpful.
Is anyone still working? Still working, have questions? Feel free to reach out.
Yeah, I can write out the solutions if anyone wants them. If not, we can move on to the next concept because it's already 8:05.
Yeah.
It took a little longer than I thought. Okay. I'll just move on then if no one has any complaints.
Yeah, I think we're good to move on.
Okay. All right. So next we're going to get into loops. So there's different types of loops. There's a for loop and a while loop. And basically what a loop does is it takes data objects such as lists and goes through them and decides or applies a certain thing or a certain action or event to every single item in that list. So here we have a list that's the numbers 1, 2, and 3. And instead of writing out, okay, I want to add 5 to 1, I want to also add 5 to 2, and I want to add 5 to 3, and doing all of those on an individual basis, we're able to do that all at once. So a for loop has the formatting of you write for, and then you're going to use any one character, or well, traditionally it's one character, any representation such as like X or N is usually used for numbers. It doesn't really matter. And then you say in whatever list you're looking at. So in this case, we had 1, 2, 3, but I can create another one that's just like 4, 5, 6. And then we're going to put a colon after that, and we're going to go to the next line. And the next line is going to be what action you want to be performed on every item in the list. So we have, just to review, for every item in the list, that X represents each individual item. In this list, you want to do something. So our example was 4, we want to print it out. And then I want to take X because X is representative of each of those items. And then I want to maybe subtract 2. So what it's going to print out is the numbers. So this was from our first for loop, but then we have 2 minus 2 is, or 4 minus 2 is 2, and then so on and so forth. So a for loop basically makes your life easier and applies the same thing to a multitude of objects in a list instead of making you do it on an individual basis. And that comes in handy when you're doing a lot of complex problems and applying a lot more complex functions other than addition and subtraction to each item. So a for loop is going to keep going. It's not going to stop until it makes its way through the entirety of the list it's given, unless you tell it to break. So you can put a break inside a for loop by putting a condition. So we know our if statements, and we say if something is true, then you do something. So we're doing that inside of our for loop, and we're saying if X, which is our variable, is equal to the this B here, then we want it to stop going through the for loop and not apply that same functionality to the rest of the list. So if we were to step by step through this, we'd say, okay, so for the first thing in this list, this is the string A. So I'm going to go and I'm going to print it out because that's the function I've decided to do. And then I'm going to check if the string A is equal to B, and it's not, so I don't do anything. So I go back up to my list and I look at the next item in the list, which is this B. So I say, all right, I'm going to print B. So it's saying print the character B. Then I'm going to check if B is equal to B, and that's true. So I'm going to break from this for loop, and then I'm going to stop, and I won't even look at the item C. Any questions on that? I know that's a little more complicated. Cool. Okay, so that's one type of loop. And then another type of loop is called a while loop. And a while loop is basically saying, as long as a certain condition is true, you're going to keep going and going and applying the same thing over and over again until it's no longer true. So here we have the variable I, we've set it equal to 0. And so we're saying, well, the variable I is less than 10. I'm going to perform this action. So this means that you're going to add plus, it's the equivalent of saying that I equals I plus 1. That's the same thing as saying that. It just, again, coding is lazy. So you try to simplify it as much as possible and make you type less. So every time that I go through this while loop and I find out that I is less than 10, I'm going to add another number and then I'm going to print it out. So as soon as it hits 10, it's going to stop and it's not going to do that. So it should print out 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, because as soon as it hits the value, it adds 1 to I. So 9 plus 1 is 10. And then it comes and checks and it says, is 10 less than 10? And that's not true. So it stops going through the loop and then it ends. So here we should get 1 through 10 and then it stops. Cool. All right, so I know this is a little more complicated, so I'll try and walk you guys through the exercises. And then that might be all we have time for, right, Ryan? Yeah. Okay. So the first thing I was going to have you guys do was create a for loop that appends the letter A to each string in a list of strings. So if we have a list called ABC, and then that list is equal to, we'll just say cat, dog, and then mouse or something. So we have a bunch of animals. So what I want to do is I want to say for everything in our list ABC. So we're going to call it ABC and then a colon. We want to append the letter S to the end. So we're going to take our knowledge from before. We're going to say X dot, or we're going to add it. So we're going to say X equals X plus the string S, and then we're going to tell it that that's the new value in the list, and then we can say print it too, just so we know what it looks like. Cool. And so then if we were to go and output ABC, again, we would get cats, dogs, and mouses, which is technically not a word. Cool. And then the second one we have is below create a for loop that prints all of the numbers in the list that are divisible by 5, which we're going to say for n in num, so we'll name num equals a list of 1, 2, or we'll say 5, 13, and 15. And then we'll say for every number in the list num, we want to determine if that is divisible by 5. So this gets a little more complicated. So we're going to say if n, and then do you remember a modulo from earlier? A modulo 5 equals 0. And then we put our colon. And if that's true, then we want to print out that number. So we're going to say print n. There you go. And those are 2 for loops. Cool. I mean, I have a lot more, but I don't think we have time for it, Ryan. You're muted.
That's okay.
Okay, cool.
Did you want to just wrap up on this one, or?
Yeah, so that's a lot of the basic functionalities, and from there you should be able to go and figure out how to make a function on your own. I have all the information here and some practice problems too, so if you guys want to take a look at the at this notebook that Will sent and try it on your own, go for it. If not, the internet's a helpful tool, and so I hope I understand that getting into coding is a little hard. The barrier to entry is there's a lot of information at once, but once you get past understanding the different data types and the different basic functionalities, it's a lot easier and it's a lot more fun. It all comes together. So I hope I was able to at least give a very brief introduction to it and maybe get someone a little more interested.
Yeah. No, Google is definitely your best friend when you're coding.
We love Google.
Yeah, being able to Google makes you a good programmer, essentially. So yeah,
Stack Overflow.
never feel afraid to look anything up. You are never the first person to do something.
Yeah.
And there is some
Thanks.
big nerd out there who's written a blog post about how to do stuff. So
Yeah. It's all about wanting to learn it and then going from there. So
yeah. So, and there are many resources both for learning Python and for doing specific either data sciencey things or stuff like that, if that's what you're interested in. Yeah, so I definitely encourage people to go out and learn and use the internet to learn, because it's easier than fundies.
Yeah. Don't take fundies.
No, do take fundies.
No, sorry.
Come be in my class, please.
We'll tutor you. Awesome. Okay. Thank you, Ryan, for having us.
Awesome. Yeah, I have a quick question too, just as a wrap up on Python. For
Yeah.
people who are maybe looking into learning more about coding, would you recommend going into this, and what is Python usually helpful for, like maybe in a business context?
Yeah, sorry, we didn't end up getting there. This took so longer than we thought. But at the very end of our presentation, there's a package in Python called Pandas, and basically it's really good for graphing data. I know a lot of marketing nowadays has to do with a lot of marketing analytics, and that's definitely where Python comes in handy, because it's a really easy graphing tool. It generates a lot of different data structures, histograms, all that good stuff.
Yeah, you can also do a lot of
really easy
analysis with it too and stuff.
Should I pull up that other page? Well, yeah, so that's what we were getting to at the end, because it's like I said, it's a lot to take in at first, but then you get to a point where you're able to generate these graphs, and it's pretty easy to do for people that aren't super familiar with coding, but it's super helpful and it looks really professional, and it lets you draw a lot of conclusions for yourself on what you're working with and how that'll apply. For people that want to do coding for marketing, which is what this is for, I would suggest looking into Python, Pandas, and then I would suggest looking at Tableau. Tableau is super helpful for marketing, and I know a lot of people in business use that. So that's where I'd suggest to go from here if people are really interested.
Awesome. Thank you guys so much for joining us. That was awesome.
Yeah, thank you for having me.
Yeah, thank you guys so much.
Yeah.
Thank you. I learned a lot.
Yeah, thank you. Same, I learned a lot.
All right, cool.
Bye. Have a nice rest of your night, everybody.
All right. See ya.
Bye.